Welcome to LNP Renewable System Integrator. Today we are going to discuss some of the basics about damper actuators. So if you are going to work in any sort of metro stations, or if you are going to work as a building management system in GCC, or if you are going to work in building automation control system, okay, we need to know some of the basics regarding this damper actuators. So today we are going to discuss what is a damper actuator, okay, where can we see this, okay, where we are using this damper actuators, how it looks like, how it works, how a damper actuator is fired, and what are the things as a BMS engineer or a BACS engineer we should know about this damper actuators. First, we should know what is a damper actuator. So damper, from the word itself we can clearly able to identify that actuator. So actuator is nothing but it is going to perform an action. Okay, so we are going since it's an electrical actuator, so there are mechanical actuators, there are mechanical dampers, but here we are going to discuss today about the electrical damper actuators. Okay, we are going to give a power supply to it and we are going to control its operation electrically. Okay, it is mostly used in the air management accessories, mostly in variable air volume units, fan coil units and air handling units, and mostly it is used in heat ventilation air conditioning systems. So the main purpose, okay, where can we see this? We can see this in heat ventilation air conditioning power plants, okay, and even in the chiller water systems also we can see these damper actuators. Okay, so actuators mainly used to control the opening and closing of the airflow in response to the thermostat, that is based on the temperature. Okay, in order to control the temperature we need to control the airflow inside that particular room. So it is like a closed loop function which is happening. So you are taking the temperature as a reference and we are going to control the opening position and the closing position of the actuators. So damper actuator has vast application. Okay, it is used in track to exhaust fans, tunnel ventilation fans, building automation system. It is used in air handling units, variable air volume units also. Even for the pressurization fans also we can control the dampers positions. So as I told earlier, if you go for a building automation system, established buildings, multi-storage buildings like malls, metro stations, there you can see these damper actuators. Okay, and even in a building where the building management system we are going to perform using the DDG controllers, there you can see these damper actuators. We are using these mostly in the actuators. As I told earlier, for the fire alarm system we are using this damper actuators. For the pressurization fans we are using it for air handling units. Okay, and even for the tunnel ventilation we are using these dampers. So a simple example of a variable air volume unit. See here we have a actuator, we have a DDC controller. Okay, so we had given a power supply to this actuator and we are controlling its operation, opening and closing position with the help of this controller. So if you go for an actuator, we can classify into two types. Either that is one actuator which performs only direct opening, full open and full close, fully opening and fully closing operation. The other one is the modulating type. The modulating type operates with a 2 to 10 volt. Okay, if we require we can take the current as a control and as a feedback also. Most importantly for the actuators, whenever we are giving a power supply, okay, if you are going to perform any sort of control operation, first you need to send a control signal and also you should receive a feedback also. Then only you can able to identify its correct position. Okay, because once we programmed, okay, we used to link everything into the workstation through the SCADA. So in the SCADA, if you want to know the perfect position of these dampers, then we should have the feedback positions also. So this is an example where it is used in air handling unit. See here we have a dampers here. Okay, supply fan, exhaust duct, and in the recirculation duct also we have a dampers. So with the help of this damper actuator we are controlling the dampers. See here, this is how it looks like. There are so many varieties. If you want to install it on the external part of the shaft, it looks like this. Or if you want to fit in internal part of the shaft, you can install like this. Okay, so this is an example of a damper actuator which is fully opening, fully closing type. It's like a digital switch it acts. These are all modulating types. Okay, these are the simple. This is an example of a actuator which is installed in the air handling unit. Okay. So this is a simple example of how a damper actuator, electrical damper actuator works. Okay, see here how it is opening, it's closing. So this is the one which we are going to perform using this actuators. Okay. So this is an example mechanically how it is working. Okay. So using the actuator we are going to perform this mechanical operation. Using the electrical actuators we are going to perform this operation, mechanical operation, opening and closing operation. So now a pretty basic idea we should all know about when wiring the damper actuators. First we should know where we need to connect our positive wire, where we need to connect the negative wire, which is the control and which is the feedback. Simple. When you take that damper actuator, okay, in your hand, or if you have a manual, or if you have a terminals, so for the common and plus hot will be the line and neutral points where we are going to give your power supply. Okay, and if it is written as Y, that is going to be input, okay, the control signal. Okay, and if it is written Y, that is going to be the U. If it is written U, that is going to be the feedback signal. So this is a simple assumption. Okay, and there are so many varieties of damper actuators, because few will operate with the 24 volt AC, 24 volt DC as well, and there are certain actuators which will operate with 240 volt AC supply also. Okay, and even multiple positions we can fix using this damper actuators, and even we can take the feedbacks, opening position, closing positions also. To take the feedbacks also we have different terminals in it. Okay, see here, this is an example of a digital type. We have a NONC contact like a switch, auxiliary switches. We can take the feedbacks or positions of this actuators. And even in certain places, okay, we can either give, okay, control signal in DC also, 2 to 10 volt DC we can give, or if you want to give as a current signal also you can give, that is 4 to 20 milliamps. Okay, and as I told earlier, it will try to work as auxiliary switches in certain places also. So based on our application we need to choose the actuator type required for us. So as I told earlier, in the air handling units, in the supply side we have a damper actuators, and also on the exhaust side we have a damper actuators, and even on the recirculation side also we have a damper actuators. So this is an example of a graphics of a air handling unit, double supply double extract type. See here we have a inlet damper, we have a recirculation damper, we have an exhaust damper. So we can monitor the damper positions we are through the feedback signal, electrical signal that we are receiving, that is 2 to 10 volt. Okay, as we discussed earlier, the same scaling methodology we use in order to show the exact 0 to 100% positions of the dampers. We are converting the electrical signal into 0 to 100% scaling, and we are showing it in the SCADA. This is an example of single supply double extract, double supply single extract example, single supply single extract example. So, and most importantly, so now we are getting directly into the BMS view, that is building management system point of view, or a building automation control system point of view. First thing is that we need to monitor the damper open status, we need to monitor the damper closed status, and we need to give the control signal. As we told earlier, it will be 2 to 10 volt, and we need to take the analog feedback also, it will be 2 to 10 volt. Okay, if there is a multiple dampers, we need to monitor all the damper signals also. Okay, so this is the IO points. What are the points that we need to monitor in dampers? Okay, the damper can be at any positions based on it can be in the fresh air side, it can be on the recirculation side, it can be on the exhaust side. Okay, thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, please contact. We had provided the contact details in it. Okay, if you are going to if you wish to work in a GCC in a building management system industry or building automation control system industry, you need to know these sort of basics. We are providing the basics in it for the building automation system and building control system. Okay, if you are an electrical and electronic engineer, if you are an electronic and instrumentation engineer, you have a very great chance to work in abroad, mostly in the GCC countries, in the building management system and the building automation control system. Okay, so we are providing training on it. So we are providing basics of design, installation, testing and commissioning. Okay, and even consultancy supports for the automation, okay, building automation and building management system, and even for if you want to know the electrical vehicle basics, okay, if you want us to train your colleges in the electrical vehicle basic designs, you can contact us. So we have provided the contact details, and also we are providing design, installation, testing and commissioning supports for solar on-grid and off-grid projects also. So you can contact us. We have provided the contact details in it. Thank you so much.